Howdy. In this video we'll be given a nice overview of how we get from 2 points on the Cartesian coordinate system all the way to the equation for a line. And along the way in the middle we'll run into distance, midpoint, and slope. So let's go here. The first thing to do is to have ourselves a couple of points. So here is point A. We'll call this one point A, and this is point B. And they're on the coordinate system. We have the y-axis here and the x-axis here. And the question that we're going to start off with is simply the distance between 2 points. And this distance, you'll notice that it's the hypotenuse for a right triangle. And we'll now give a new point. We'll give this imaginary point C down here a label. And that way we can see that really we have the hypotenuse and we have the 2 legs for a right triangle. So the Pythagorean theorem would allow us to say that AB squared is equal to AC squared plus BC squared. And that's a nice simple formula to think of, and really what we want to do then is to find AB itself. And all we have to do is take the square root. And because distance is positive, we can ignore the negative option for square roots. So it's really just AC squared plus BC squared, and that sum square rooted. Now the question, I guess, is what is AC? And A is a particular point with an x and a y coordinate, and B is a particular point with an x and y coordinate also. So perhaps what we need to do is imagine what these points might be. And I'll call this this point here x sub A and y sub A. And that will be the x and y coordinate for point A. And you can imagine what we'll do here now. We'll say that the x coordinate for point B is x sub B, and the y coordinate is going to be y sub b. Now AC is going to be the difference between the y coordinates. It's this height here. So AC we can replace with, let's give ourselves a little more room to work with. AC we can now replace with the difference in the y coordinates. So we could take y sub b minus y sub a. Oh, let's actually back up there. Let's pick it the other way around to be nice and consistent. We'll start with the easiest possible option here, which is from the high point to the low point. It doesn't, in the end, doesn't particularly matter, but we'll start with y sub a minus y sub b, and we'll square that, and then we'll have x sub a minus x sub b squared. And there we go. This is the general idea of the distance formula, that we take the change in y squared and we add the change in x squared and we take the square root of that sum. And a more technical formula might look something like this, that we have the distance is equal to the square root of the change in y squared plus the change in x squared. And this little delta symbol, this triangle, we need to be very familiar with this. This is going to be, delta is the symbol, its meaning, and we use it for change. Now the next thing along the way is to look at midpoints. And again we'll have our points A and B here. So here is B up here. We'll call this one A. And now what we're looking for is to find the coordinate for the midpoint. I'll call this point M here. And you can notice that because it's the midpoint, I could make this like a series of steps. And that as I go from A to B, it's going to be halfway. So we could imagine that the x coordinate for M would be the x coordinate for A plus 1/2 of the distance from B to A, which is going to be x sub B minus x sub A. Now if I distribute the 1/2 onto these two terms here, we can see that that's going to be x sub A plus 1/2 x sub B minus 1/2 x sub A. And that 1/2 of x sub A subtracted from x sub A leaves us with a 1/2 of x sub A. So there we now have 1/2 of x sub A plus 1/2 of x sub b. And I'll now factor out the 1/2, and that leaves me with 1/2 of x sub a plus x sub b. And perhaps more familiarly, if I now take that sum of x sub a and divide it by x sub divided by 2, x sub a plus x sub b over 2, we can see that in point of fact that the x-coordinate for the midpoint is really just the sum of x sub a and x sub b divided by 2, which is the average of x sub a and x sub b. And likewise, we'll find that the y-coordinate is going to be simply, for the midpoint, will be simply the y-coordinate for a plus the y-coordinate for b, all divided by 2. Next up are slopes, and we'll just practice finding slopes a little bit and talk about the different types. In general, the idea of a slope is how steeply we go either up or down as we move from one point to another, and by the most usual methods, we will consider going from a point A to a point B. We consider going from left to right, and so we'll talk about a positive rise as we go from left to right for this point AB, so this would have a positive slope. And over here, as we go from point C to point D, we actually go downward, so we'll talk about this as a negative slope. There are two other cases, one where we have horizontal points, and so when we look at the rise as we go across from point perhaps E to F, we have no rise at all. So in this case we'll have a slope of 0. And sometimes we'll even have 2 points that are above each other, maybe G and H. And in this case we have an undefined slope. There is no run for us to divide the rise by. So we actually end up with a number compared to 0, which is undefined. So let's practice a little bit. Pick 2 points. How about we'll take the point -2, -3, and we'll pick a point up here in the first quadrant, perhaps 3 and 1, and we'll try to determine the slope as we go from this first point. Let's call this point A, and point B over here. And if we simply draw in a Pythagorean right triangle, we can get a little feel for what's going on. And here's our hypotenuse now. So we're looking at this rise and comparing this to the run. And the rise, you'll think of the last thing we did. This is really just the change in y. So the slope we will define as the change in y over the change in x. And in our example coming up shortly, we'll practice that. But this is our most important idea right here.